So I'm supposed to teach this? But ain't a professor or a teacher supposed to do that? So why am I teaching this? Okay then? Yo! This has to reach 15 minutes? Well, I guess I'm doing this now. Welcome to class. You're late. Anyways, today's topic is on reflexión. The thing that you see in the mirror when you are driving and the car behind you turns on their night lights. The freaking law of reflection! Now, where do normal human beings see reflection in everyday life? Well, you'll be glad to know that you see reflection every single hecking day. Reflexión. 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 Well, after that, I guess I should start with a quick little history lesson of when this first was discovered. Before I get to the juicy stuff, of course, at least, Because honestly, it's not much. I had to get stuck with the easiest topic. Anyway, back in the year 300 BC, hold up. What the heck? That's freaking old. What do these ancient people do in their free time? Jeez. Oh, also, I don't know how this might have went down, so I'm making this next story up. Anyways, back in the year 300 BCE, some dude named Euclid, yeah. Some dude named Euclid done dropped some random mirror on the ground. Yes, apparently they had mirrors back then. And if it wasn't a mirror, it had to be the water. Anyways, point is, when he went to go pick it up, he saw that the sun's light was reflecting off into his eye. At first, he didn't care much about it, because, who pays attention to that annoying sunlight anyway, am I right? Anyways, just until a few seconds, he suddenly thought to himself, this is big brain time. And then, of course, he went on to define what is called the law of reflection. It meant that light travels in a straight line and that anything that it bounces off of will bounce off at the same angle that it hit. Now, for those of you that don't know anything about physics, it means light hit this, then does a bamboozle. Now, to the person that actually wants to learn what that meant, it means that the angle of incidence equals the angle of reflection, or as so. Now, I wish I was kidding about this next part of what I'm about to say, but I'm not. That's literally the only equation in my section that I have to cover, which is why I'm a little ticked at the amount of time I had to say that. 15 minutes! Well, on the bright side, I can now give you a few examples of how this can be applied in physics equation. In other words, let's get to the juicy stuff. Let's start off with an easy one, shall we? You have been hired by the government to shoot down drones using a laser. But because of your irrational fear of looking up, you have to aim the laser using a mirror that's on the ground. A drone appears and you shoot that laser towards the mirror at an angle of 30 degrees to the horizontal. What is the angle of reflection? Simple enough, I believe. So if the angle of the horizontal is 30 degrees, then all we have to do is find the angle of incidence. Then the angle of incidence equals the angle of reflection.
But George, we can also do it from the opposite side because the angles on the bottom are equal to each other, so it's much easier.
Do you want to learn or not? As I was saying, 30 degrees to the horizontal to find the angle of incidence. We merely just have to subtract 30 degrees from 90. Since the angle is perpendicular to the ground, and let's see here, 90 degrees minus 30 degrees is 60 degrees. And since the angle of incidence is equal to the angle of reflection, then the angle of reflection is 60 degrees. See? Easy enough. Let's kick it up a notch. Now the government wants to make your life hell. Why? Because they give you a second mirror that's on a vertical wall to shoot the drones that's connected to the first mirror at an angle of 120 degrees. You see a drone coming and you shoot the laser once again, but at an angle of 40 degrees to the horizontal. What is the angle of reflection that the laser bounces off at the second mirror? So to start this, we just want to find or figure out what the angle of reflection of the first angle is. And if we follow the first pattern from the first example, then this minus this is equal to this. And since this is equal to that, then that's where we are at the moment. The angle below the reflection angle is equal to the angle that you shot the laser at. So that means, ooh, there's a triangle right there. With two known angles, we can find that last angle of the triangle real quick then. Well, let's see, let's put my mental thought process into perspective here. If the triangle equals 180 degrees, and the two angles that we know add up to 160. So if we minus that from 180, then our result is 20 degrees. So that means the angle on the horizontal of the second mirror is 20 degrees. And now we must find the angle of incidence. And it's literally the same process as before. So basically, this minus this equals that. And that is the angle of incidence of the second mirror. And that means that the angle of reflection is equal to 70 degrees. Honestly, that's a lot of explaining for just one simple problem.
Hold on. Huh? What's that out here?
Can it get harder?
Well, thank you for asking. I was just about to. The government hates your terrible shot, so they added a third mirror for you to fix your aim.
Now, how that's gonna fix the problem, I have no idea. We're just gonna go along with it, okay?
Anyways, this one is connected to the second mirror at an angle of 80 degrees. Usually, we wouldn't already know these other angles, but because we already solved these other angles, this should be pretty easy. And I just contradicted myself, didn't I? Well, oh well. Let's just get back to the problem and...
Another triangle.
And once again, we know what two of the angles are. That means that the missing angle should be 180 minus the other two angles. Which means the missing angle is 80 degrees.
Huh?
And the angle of incidence can now be found, meaning that if we do 90 degrees minus 80 degrees is 10 degrees, which means the angle of reflection for the third mirror is 10 degrees. And I think I basically just failed at trying to make this harder. Frick. Well, I've literally stretched this out as far out as I can. I don't know if this is going to be on your test, but if it is, then I hope I explained enough.